7.7, solving inequalities using multiplication or division. So I took a picture of what your math page would look like, and I decided to kind of go this route with it right now. So I want you to write this stuff down. This is what's nice about these sections 7.6 and 7.7 is we've already really covered it, except for we did equations instead of inequalities. So it's the same concept, but we're using inequalities instead. So let's look at this. Let me get the highlighter out here. Multiplication property of inequality. Okay? When you multiply each side of an inequality by the same positive number, the inequality remains true. So when we multiply, okay, not add or subtract like we did last section. So let's look at the examples. They give us 8 is greater than 6. If we were to multiply 8 times 2, it equals 16. On the other side, if we were to multiply that 2 over there, it becomes 6 times 2 is 12. Does that keep our inequality true, that 16 is greater than 12? Well, yeah, it absolutely is. So that makes more sense, that because we did the same thing on each side of the inequality sign, that it still held true. Let's look at it with algebra. We have x divided by 4 is less than 2. So if I take and I multiply this side by 4, remember that's what kind of gets us out of it, okay? It kind of gets rid of our 4's and it leaves us with x. But again, I have to do the same thing over here, and if I multiply 2 times 4, it is 8. So now we're left with x is less than 8. So if we were to put in any number where x is, that would mean, let's say that we did 7, or let's do 6. So 6 divided by 4 is less than 2, okay? So that kind of holds true, which is nice. And that's kind of what that property is talking about. Let's look at the other property. So our division property of inequality. Same concept. If we divide each side of an inequality by the same positive number, the inequality remains true. So over here, if we took 8 and divided it by 2, it becomes 4. If we take the 6 and we divide it by 2, it becomes 3. Does that inequality still hold true? 4 is greater than 3. Yeah, so that works fine. Algebraically, if we took 4x is less than 8, we have to divide it out by 4, which gets rid of those 4's, leaves us with x, and then we do the same thing over here and leaves us with 2. So that means no matter what it is, whatever our problem ends up being, x is going to be less than 2. Example 1, solving inequalities using multiplication. So simply the directions are to solve and then to graph the solution. We learned how to graph the solution back in 7.5, so this is just a kind of a refresher. I think we had to graph the solution back in 7.6 as well. So here's just another example of what we have to do, but we have to solve this inequality. Okay, we have x over 5 is less than or equal to 2. So what we have to do is realize that we have division, okay? When we have a fraction, that means division. So we have to do the opposite, which we should already know that we're going to be using multiplication. That's what the example is telling us. So I am going to multiply this side to get x by itself. I want this to look just like this. In order to get rid of my 5, I have to do the inverse operation and undo the division. So I'm going to do the inverse, and I'm going to flip this over like that. So that gives me and gets rid of my 5's, okay? So I basically just multiplied it by 5. We leave the 1 on there so it helps us out, okay? remember, what I do over on this side, I also have to do on this side. So now I'm going to multiply this side by 5 over 1, but I technically don't need to put the over 1 because 2 times 5 is 10. So this becomes my answer, okay? And this is how we can do our check, and that's why they want us to graph the solution. So now I'm going to put it on a number line, okay? So here's my number line. I'll pause it so it goes quicker. I should probably tell you that since I have such a large, I shouldn't say large, since I have 10, I'm going to actually start with my 10, okay? And then I'm going to put a few numbers to the right and a few numbers to the left. So they don't necessarily have to show negative numbers, okay? So we start with what we have. We have 10, so that's the number we graph by putting our circle in. We check out what our symbol is, and our symbol has the line underneath it. So that signifies that it's colored in, okay? So we color it in. Then we have to figure out which direction X could be, okay? So we test a couple. Let's test out 13, okay? If I put 13 in here, would it make sense? 13 is less than or equal to 10. No, it's greater than. I'd rather have $13 than $10. Okay, let's test out 7. 7 is less than or equal to 10. Yeah, that works out. So because that works, 8 works, 9 works, and 10 works, that means our arrow is going to be colored in going this way, in this direction. So you'll color that in. So this would be what a final answer would look like for an example like this. Let's try one more. P divided by 3 is greater than 2. And as I've told you before, if you set it up like this, P divided by 3 is greater than 2. It's just a little bit easier to see that you use that reverse or that inverse operation. So I've got division. I'm going to multiply it by its inverse. Okay, so it's technically 1/3, so I'm going to flip it over. It's 3 over 1 now. That gets rid of that, and I'm left with P. Now I'm going to do the same thing on this side and multiply it by 3 over 1. I don't really need to do anything with the 1. 2 times 3 is 6. So this concludes my answer. P is greater than 6. Now that I've solved it, now I'm going to go through and put it on, and I'm going to graph it. So I put a few numbers on my number line both ways. I'm going to start by circling my 6, because that's what we're dealing with. I check my inequality sign. There's no line underneath it, so I keep my circle open, okay? This would get, that's supposed to be a P. That would get your whole problem incorrect if you circled and filled that in, okay? That's really important. That indicates that 6 is not a solution to what P equals, okay? So P is greater than 6, so we can test out a couple of them. Let's test out 3. 3 is greater than 6. No, we know that's not true. Let's test out 9. 9 is greater than 6. Yes, so you will color in to the right and it should look like this. Remember, the circle on the 6 is left open. Example 2, solving inequalities using division. So this one is just the opposite, and we'd have a problem that looks like this. 4n, or 4 times n, is greater than 32. So now we recognize that this is multiplication, and to get n by itself, I have to get rid of my 4. To get rid of 4, I divide it out, because 4 divided by 4 gives me 1. And if I have one n left alone, then I know that anything that equals n times 1 will always be itself. So n could actually equal 4 million. 4 million times 1 is 4 million. N could equal 8. 8 times 1 is 8. So that holds true with all of that. So now I get n by itself, but if I do that on the left side, I also have to divide 4 on the right side. So 32 divided by 4 is 8. So what it's telling me is that the solution is n is greater than 8. And then we put it on a number line. So we make our number line. We start off with circling our 8, because that's the part of the problem that we're focusing on. We realize, is it open or is it closed? We keep it open because there's no line underneath our inequality sign. And then we test out a couple numbers. Let's start with 5. Is 5 greater than 8? No. Is 11 greater than 8? Yes. So that means our arrow will go to the right direction. And this is what your graph should look like. We'll do one more and be done. 11k is less than or equal to 33. I want to get k by itself, so I get rid of my 11. 11 divided by 11 is 1. Whatever I do on this side, I do on this side. 33 divided by 11 is 3. Now I'm left with k is less than or equal to 3. Now I'm going to do my number line, and it should start off like this. So I have a few points on each side. I circle my 3. I check my inequality sign. There is an underline, so that means I color it in. Then I have to do a couple tests to see if it works out. So if I use 0, 0 is less than or equal to 3. Yes, that is true. Let's just check 5 just in case. 5 is less than or equal to 3. No, it's more than 3, so that wouldn't hold true. So your arrow would go in this direction. So this is what your answer would look like. And that kind of concludes 7.7 for us. We have some practice problems to do, and you should be good. Let me know if you have questions.